All right, thank you for joining me for my second attempt to make this video. The first time was so bad. I was putting points in the wrong spots. My mouth wasn't communicating with my brain. Oh my gosh. Hopefully this time I do better, or we might make a third video. Okay, guys, we're going to make compositions of transformations today. Okay, basically a composition is just one transformation followed by another. Okay, now here we have an example of a glide reflection. Okay, it's mapping the triangle JKL onto triangle J prime, K prime, L prime, and it is the composition of first a translation along, add this right here, vector V, followed by a reflection across line L. Okay, so you can see that first my little pre-image is traveling along vector V in this direction. Okay, and then we're reflecting it in the line L. Okay, so if we have an image that is congruent, if we're doing two isometries, so not dilations, but if we're doing isometries, and we have the image after each transformation congruent to the previous one, then we have, by the transitive property of congruence, the final image congruent to the pre-image. So this leads us to the theorem that a composition of two isometries is an isometry. Now, put off to the side here, dilations are not isometries. Okay, if I'm doing a dilation, I'm changing the size. Okay, so that's not, if you have some sort of a composition that has a dilation in it, you're not going to get congruent images. Okay, so that is the exception to this rule. We're talking about rigid transformations. Okay. Here is the one that I just could not do a few minutes ago. And I'm going to try it again. Because if at first you don't succeed, try again. It's not hard. I was just having brain farts and I couldn't see the axes and it was just struggle. So we have to draw this composition of isometries. We've got triangle KLM. It's got these vertices. We're going to first rotate it 180 degrees about the origin, and then we're going to reflect it in the y-axis. Okay, so let's plot our points. Okay, K is at 4, -1. That's K. L is at 5, -2. Ew, I don't like where I put K. L is at 5, -2. And M is at 1, -4. Yeah, this is the point I totally just put in the wrong spot last time. Okay, there's our little triangle. We're going to rotate him 180 degrees about the origin. So we need our coordinate rule. So this is the rule. We take our x and y and we transform them like this. We don't switch their spots, we just change their signs because we want them to go 180 degrees. So -x, -y. We want their opposites. All right, so I'm just going to change the signs to the opposites on all of my points. So K prime will be -4, +1. L prime will be -5, +2. M prime will be -1, +4. See, this isn't hard. I just don't know what I was doing. I was struggling. All right, now I plot these points. K is at -4, 1. -4, 1. That's K prime. L prime is at, I keep doing that. I keep putting it where I can't write the other one. Okay, that's K prime. L prime is at -5, +2. And M prime is at -1, +4. Okay, so that is my fun little rotation. Now I'm not done because I still have to reflect that rotation, that image, across the x-axis. So let's do that. We need our rule, so we need to know what we're doing to the x and the y's. So if I want to reflect it over here, I want my y values to stay the same, but I want my x's to change sign. So this is my rule. X, y maps to, change the sign on x, keep the y value the same. Okay, so now I'm using these primes up here. So I'm going to change the sign on the x and keep the y. Change the sign on the x, keep the y. Change the sign on the x, keep the y. Okay. 4, 1. Boop. 5, 2. Oop, that's 6, 2. See? You gotta watch me today. Woo! And then 1, 4. 1, 4. Okay, that's M double prime. The first one I did was K double prime. And this is L double prime. All right, now, what I'm hoping that you can see is after all of that rotating and reflecting, what we end up with is something that could have been just a reflection in our x-axis. If you look at these two, isn't that fun? Oops. All right, next one. Okay, so I've got JKL with vertices 1, negative 2. That's J. K is at 4, negative 2. And L is at 3, 0. Okay, that's L. Okay, we're going to reflect that across the x-axis and then rotate it 180 degrees around the origin. Okay, so let's draw the line of reflection in here. Boop, 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 boop. X-axis, that's the line y equals 0. Notice that L is on our line of reflection, so L is not going to move. All right, let's remind ourselves what the coordinate rule is for reflection across the x-axis. It is x and y map to. We're going to keep our x values the same, but we're going to change the sign on our y values. We're going to make them opposite. So keep the x, change the sign on the y. All right, so J prime will be keep the 1, change the sign on the negative 2 to positive 2. For K prime, keep the 4, change the negative 2 to positive 2. For L prime, keep the 3, change the 0 to 0. Do you see? It didn't change. We knew that was coming. So here's our reflection. L prime stays the same. K prime is here. And J prime is there. Okay, now we need to rotate that 180 degrees about the origin. Now, it doesn't matter which way we go 180 degrees because they have the same rule. So we can go clockwise or counterclockwise. In my head, I'm going to be going counterclockwise because that's the positive direction for math. Remind yourselves of the rule. X and Y map to. Keep them in the same spots, change their signs. The opposite of X and the opposite of Y. So that'll be negative 1, negative 2, negative 4, negative 2, and negative 3, 0. Opposite of 0 is still 0. So J double prime goes to -1, -2. K double prime goes to -4, -2. And L double prime goes to -3, 0. So if you look at my pre-image and my final result, you see that I end up with just a reflection in the y-axis. After all of that reflecting and rotating. That's fun. Okay. Next up. All right, we've got triangle PQR. Did I skip one? Yep, I did. Sorry. Okay, we have to translate PQR along the vector -2, 1, then reflect it across the x-axis. All right, let's plot these points. P is at 5, -2. Q is at 1, -4. And R is at -3, 3. Okay, so first we have to do our translation. So our translation is telling us what to do to the x's and y's. So for point, I have to subtract 2 from all of my x's. So I'm just going to write a -2 under all of these. Okay, and then I'm going to put all of my x coordinates first. So 5 minus 2, that's 3. 1 minus 2, that's -1. -3 minus 2, that's -5. If I don't switch back and forth, like, I'm less likely to make a mistake. So you learn things like this when you have a brain like mine. All right, now if I want to do the y's say that I have to add 1, plus 1, plus 1, plus 1. So -2 plus 1 is -1. -4 plus 1 is -3. 3 plus 1 is 4. Okay. So now I can plot my points. I've got 3, -1. That's here. That's my P prime. Okay. My Q is -1, -3. Right there, Q prime. And my R prime is here. Okay. Now we have to reflect that across the x-axis. So, going across the x-axis, I want to keep the x values the same, but I want the y values to be opposite. Okay, so that tells me my rule. My rule is x and y map to, keep the x, change the sign on the y, opposite of y. So, keep the 3, make the 1 positive. Keep the -1, make the -3 positive. Keep the -5, make the 4 negative. Okay, so P prime is going to go to 3, +1. This is P double prime, sorry, P double prime. Okay, now Q double prime is at -1, +3. And R double prime is at -4, -5, sorry, -5, -4. R double prime. Yeehaw. Okay, so we haven't done any dilations yet, so all of these are producing congruent figures because these are all isometries. We're not doing dilations right now. Okay. Okay, so now we have to reflect triangle PQR across the line y equals x. Okay. So the line y equals x, guys, is this one. Okay. All of the y values are equal to the x's. So when my x is 1, my y is 1. My x is 2, my y is 2. My x is -5, my y is -5. We have to, where is P? Point P is at 5, -2. 5, -2. Q is at 1, -4. And R is at -3, +3. Oh, is that the same one? Okay, that's fine. Okay, so okay, sorry, I had a brain fart. When we reflect in this line, what this does is it swaps our x values and y values. So the rule is x and y map to y, x. So I just take my x and y and trade spots. So P prime is going to be -2, 5. Q prime is going to be -4, 1. And R prime is going to be 3, -3. Okay, let's plot those. -2, +5. That's P prime. -4, +1. That's Q prime. And 3, -3. That's R prime. Ooh. Ooh, that's pretty. It's kind of like a little bow tie. Okay, now we need to rotate that 90 degrees about the origin. If it doesn't specify a direction, guys, we have to assume that we go clockwise. Counterclockwise, because that's the positive direction. Okay, so we're going to go clockwise. So the rule for going clockwise, oh my gosh, is that we trade spots with the x and the y. Okay, and let me think about this. You think about it too. I have to pause the video while I'm at break. Okay, it's this one. This one is opposite. Okay, here we go. So we're taking all of these points and applying that rule to them. So I'm going to switch the spots of the 5 and the -2, and then I'm going to make this negative, change that sign. So 1, -4, change the sign on the 1 to a -1. -3, 3, change the negative to a positive on the first 3. Okay, plot your points. -5, -2 is here. That's P prime. -1, -4, that's Q. Whoops, that's double prime, guys. Q double prime. 3, 3. That's R prime. Double prime. Wowza. That was fun. Okay. So these, I don't know if you're like a memorizer, you might want to memorize these. I'm not a memorizer. I'm kind of a draw a picture and figure it out kind of a person. But these are some equivalent, like this composition is equivalent to this kind of rigid transformation. So if we have, where's our starting figure? Okay. Oh, here, they're labeled 1, 2, 3, duh. Okay, so if I take figure 1 and reflect it in the y-axis, okay, and then I reflect it in the x-axis, that is equivalent to rotating 180 degrees about the origin, or about whatever point I'm rotating about, the intersection of those lines, okay? Here it happens to be the origin. So we can draw our own picture. So we're going to draw intersecting lines. Let's make ours perpendicular, okay? And I find that right triangles are easier for me to keep track of which side is which. So I'm going to start with my right triangle here. Okay, and then I'm going to reflect it in, let's say, the y-axis. I should label them like they did. So we can call this 1. We'll call this one 2. Now let's reflect it in the x-axis. Okay, here's 3. That is the same as if I had rotated 1 all the way around 180 degrees to the spot where 3 is. Ta-da! Okay. Okay, a glide reflection is the composition of a reflection and a translation where the line of reflection is parallel to the direction of the vector line v for the translation. That's the one we had at the very beginning. So you can see that the vector is parallel to the line of reflection M. All right, I don't have much to say about that one. Oh, this one's pretty easy. So basically, if you have two rotations at the same center, you can add them together and get like one monster rotation, is what that says. So here I have initially a 90-degree rotation plus another 45-degree rotation, but they have the same center, so I can add them together and get a 135-degree rotation. Easy peasy lemon squeezy. Is that the end? Yeah. Oh, I skipped this other one. I was like, I know there's another one. Here it is. All right, this one's my favorite. Okay, so this one is saying if I have parallel lines, boop, boop, and I take my figure and I reflect it over each of those parallel lines, what I get is a translation. So here's what that looks like. Here's my little triangle. Okay, I'm going to reflect it across my first line. Okay, now I'm going to, here's 1, here's 2. Now I'm going to reflect 2 across the second line. Oh, okay, hold on. My board is being dumb. Reflect it across my second line. And basically I just got a translation from 1 to 3. It just slid. Ta-da! That's the end.